Hi, I've got some extra information for you about the week 3 assignment. Hopefully this helps make it a little easier. So on the assignment, hopefully you've watched through the video and so you got the background that you needed. And then there's the two simulations. I've got those open in these tabs here. And then I also added down here, this is the link to our notes. So those were the notes that we did way back when we were still together on Newton's three laws. So that'll help you particularly with question number 2, okay? So our first question is, gravity always exists between two objects. In the simulations, how does the force of one object, or of object 1 on object 2 compare with the force of object 2 on object 1? So here is what I'm trying to say with that one. Okay, just it's fine. Anyway, so it might be a little bit easier to look at the numbers if you click scientific notation instead, and then you can compare those numbers a little easier. But what I want you to see is that every time, if I move them closer together, then that number does increase, but notice it's the same for both of them. This says the force on 1 by 2. So that means the force of the red ball on the blue ball is this arrow here. The red ball is pulling that blue ball to the right. And the same is going on vice versa. So the force of M2, or force on M2 by M1. So that's the force on the red by the blue. And the blue one is pulling it to the left. So if I move those closer, we see that that force gets bigger, but the number is the same for both of them. Same thing if I scooch them apart, the number goes down, but it's the same number for both of them. And if I change their masses, still the numbers are the same size. Same size, opposite direction. That's what I'm looking for on question number 1, is that those values are always the same. In question number 2, I'm looking at the 3 laws. Which of those talks about equal and opposite forces? So think about that when you go and look at those laws, okay? Next, when the mass of one or both of the objects increases, what happens to the force between them? So that's where you're going to manipulate the mass. If you increase the mass of one of them, we see that that number goes up. Increase it, the other one, number goes up. It doesn't matter if you're increasing one or the other, or both of them, it's always going up. And then when we talk about the distance between the masses, when that increases, so if I increase the distance between them, that means moving them further apart. What happens to that force value? How does that force change? Then in number 5 and 6, we're looking at the gravity simulation in particular. So if you look at that, what happens to the velocity of the Earth when you increase the mass of either the Sun or the Earth? Well, if I get this going, since I'm asking you about the velocity, it's going to help to have the little velocity check on. And it's not always the same size as it's going around. Notice that it gets kind of like closer to the Sun over here. If we put the grid on, then you can kind of see that it's going to get closer. Put the path on, then you can see it traces a little path around. And sometimes it's closer to the Sun and it speeds up then, and then sometimes it's further away and it's not quite as fast. But if I increase the mass of the Sun, do you see how that velocity increases? So what do you think is causing that velocity to increase? If I increase the mass of the planet, you might see it increase a little bit, but not too much. It pretty much stays the same, but you definitely see it when you increase the mass of the Sun. If you increase it too much, you can actually get it to crash into the Sun, which, yeah. But, so what did you see happening with that velocity? We saw that velocity increasing as that mass got bigger. Why do you think that happens? Why does it speed up? What causes it to speed up when we increase the mass of the sun? And then the last question is, can you find a way to get the moon to stop orbiting Earth? So we can do that either in this simulation or in this simulation. So if I have, there's the moon orbiting the Earth, and if you need to get those paths out of there so you can see better, that's fine, just uncheck them. So then just try some things. Maybe you make Earth's mass much smaller. Or maybe you could try making the sun's mass bigger. Oh, make the sun's mass bigger. Does that do anything to it? Oh, essentially. So that's what I mean when I'm talking about can you get the moon to stop orbiting the Earth, and how did you do it? Okay, so hopefully that helps you see what you need to say in answering these questions. Let me know if you still need some additional support after watching this bit. Thank you for reaching out. Bye.